In this video, we are going to take up the case studies on real numbers of class 10th, that is chapter number 1. And let us see what for the first case study. Now, the first case study is real numbers. Here, to enhance the reading skills of grade 10 students, the school nominates 2 or more of your friends to set up a class library. There are 2 sections, section A and section B of grade 10. There are 32 students in section A and 36 students in section B. So this is the situation where a few questions will be asked and we need to answer the thing. So you need to understand what. So here in section A, there are 32 students, and in section B, there are 36 students of class or grade 10. Okay. Now, based on this, we have a few questions to be answered. So now see the first question. What is the minimum number of books you will acquire for the school class library so that they can be distributed equally among students of section A or section B? So we have got 4 options here. Now I have to see which is the correct one. So let's start with it. See, take the first question and try to answer them. See, here the number of students in section A is 32. Number of students in section B is 36. So the total number of books you will require for the library so that they can be distributed equally among the student is the LCM of 32 and 36. So how do you find the LCM? We factorize 32 and 36. So the factors of 32 is 2 multiplied 5 times, that is 2 raised to 5. And the factors of 36 is 4 nines are, that is 2 square into 3 square. So this is the factors of 36. This is the factor of 32. Okay. Now to find the LCM, you have to consider all the factors and those factors having the highest power. Factors having highest power must be considered. So now LCM of 32 and 36 is, now you see this and this, 2 is a common factor. But the highest power is here 5, here is 2. Highest power is 5, so it is 2 raised to 5. Next factor is 3. Here it doesn't have 3, so here 3 raised to 2. So 3 raised to 2 is a factor. So 2 raised to 5 into 3 raised to 2 is 32 into 9, that is 288. So that means they have to acquire 288 books for the class library so that they can be distributed equally among section A and section B. So this was the first bit answer. Now let us see the second question. If the product of 2 positive integers are equal, product of 2 positive integers are equal to the product of HCF and LCM. This is true, okay. So then HCF is, that means he wants you to find the HCF of 32 and 36. So the factors of 32 is 2 raised to 5, which we have seen earlier, and 36 is 2 raised to 2 into 3 raised to 2. Now when you want to find HCF, HCF is the common factor having lowest power. Now if you see these two, the factor which is common to both is 2. And the lowest power is here 5, here it is 2. So 2 is the lower power. So 2 raised to 2, that is 2 into 2, that is 4. So 4 is the highest common factor for these two numbers. Okay. HCF of 32 and 36 is 4. So your answer B is the correct answer. Now the third bit question is 36 can be expressed as a product of its prime as. Now we have seen here first case, second case we have seen how we have expressed 36 as a product of prime because 2 and 3 both are primes. So 2 raised to 2, 3 raised to 2. So 36 can be expressed as this. So from among these, if you see 2 raised to 2, 3 raised to 2 is in the first option. So your answer is option A. Okay. Now look at this. Question 4. 7 into 11 into 13 into 15 plus 15 is it a prime number, composite number, neither prime nor composite, or none of the above? Now you see, what is a prime number? A prime number is a number which has only two factors, that is 1 and the number itself. In this case, you see it is multiplied by four numbers. That means the product will be a factor of 7, it is a factor of 11, it's a factor of 13, it is factor of 15. So it has got four factors. When it has got four factors, that means it has got more than two factors. That is, it is no more a prime number, it is a composite number. Therefore, your answer is answer B, because it is having more than two factors. Now, fifth bit, if P and Q are positive integers, P is a number, an integer, Q is another integer, and P can be expressed as A into B raised to 2. And Q can be expressed as A square B. So these are the two numbers P and Q. They want you to find the LCM of P and Q. LCM is what? The common factor with highest power. So if you see A is a common factor, highest power is 2. So A raised to 2. Then B is also a common factor, and highest power is 2. So B raised to 2. So LCM of P and Q will be A raised to 2, B raised to 2. A raised to 2, B raised to 2 is the second option. So your answer is B, B bit. So option B is the LCM of P and Q. That is A square, B square. I think it's clear. So case study is nothing but a situation is given and you need to answer a few questions below it. That's all. As you do in English of comprehension, para is given and you have to answer for the same thing. It is it's a case study. We use the word case study, a situation. That's it. So now let's go to the next case. That is case number 2, case study 2. In case study 2, a seminar is being conducted by an educational organization where the participants will be educators in different subjects. The number of participants in Hindi, English, and mathematics are 60, 84, and 108 respectively. That means number of participants in Hindi is 60, number of participants in English is 84, number of participants in mathematics is 108. Okay, so this is it's a seminar for one subject. So the first question is, in each room the number of participants are to be seated and all of them be in the same subject. Okay, hence maximum number of participants that can be accommodated in each room are. Now you see, you have to have the two conditions. Number of participants in each room must be same and the participants must be of the same subject. You cannot mix the subject teachers. That means number of participants and the subject must be same and they must be accommodated in one room. So how many participants can be accommodated in a single room having same equal number of participants and the same subject? Now let us see. So here the number of participants in Hindi, English and mathematics is 60, 84, 84. So let's factorize 60. 60 can be written as 2 raised to 2, 3 raised to 1, 5 raised to 1. 84 could be written as 2 raised to 2, 3 raised to 1, and 7 raised to 1. 108 can be written as 2 raised to 2 into 3 raised to 3. The maximum number of participants that can be accommodated in each room is the HCF of all these three numbers. When you say HCF, what we have to do? We have to take the common factor and the lowest power. So if you see here 2, 3, 5, 2, 3, 7, 2, 3. That means 2 and 3 are only common to all the three numbers. So 2, let us write 2. Now see which is the lowest power. Lowest power of 2 here is 2 here, here it is 2, here also 2. That means the lowest power of 2 is only 2. Now 3. 3. Here, power of 3 is 3. Power of 3 is 1. Power of 3 is 1. So that means lowest power is 1. That is 3 raised to 1. So 3 raised to 2 into 3 raised to 1. That is 2 raised to 2 is 4. 4 into 3 is 12. So HF is the common factor having lowest power. So that means 12 is the, that means each participants, there are 12 participants in each room. Okay, 12 participants means option B. So your answer is B. What is the minimum number of rooms required during the event? Now, how many rooms you will require? Now, you know total number of participants. This many participants are there. 60, 84, and 108. So, and we know that in each room there should be 12 of them. So, how many rooms you will require? So, number of rooms for Hindi participants, we have got 60 participants. In each room there are 12. That means you need 5 rooms for Hindi participants. Number of rooms in English participants, 84 participants are there, divided by 12 because there are 12 participants in each room. Therefore, you need 7 rooms. Number of rooms for mathematics participants is 108 divided by 12, that is 9 rooms. So that means total number of rooms how much you require? 5 plus 7 plus 9. 5 plus 7 plus 9 is 21 rooms. So totally you need 21 rooms to accommodate all the subject teachers. In the number of teachers in each room is same, and the subject of each room teachers are is also same. Subject is same and number of teachers in each room is same. So 21 room means option D is your answer. Now he is telling you find the LCM of these three numbers. LCM means you got to write the factors. You have to, when you say LCM, you have to take all the factors into consideration. So if 2 is a common factor, write down 2 and take the highest power. Highest power 2, 2, 2. So highest power is 2 only. Then 3 is a common factor. 3 raised to 1, 3 raised to 1, 3 raised to 3. 3 raised to 3 is the highest power. So take 3 raised to 3. Then 5. 5 raised to 1. There's no 5 here. There's no 5 here. So 5 raised to 1 should be taken. Then 7. 7 raised to 1. It's neither here, it's neither here. 7 is because when you are finding LCM, you have to take all the factors and with the highest power. So 2 raised to 2 into 3 raised to 3 into 5 into 7. 2 raised to 2 is 4. 3 raised to 3 is 27. So 4 into 27 into 5 into 7 is 3780. 3780 is the LCM of 60, 80, and 84 and 108. Now, fourth bit. The product of HCF and LCM of these three number is. You want the product of HCF and LCM. LCM we just now calculated in bit 3, 3780. And HCF we have calculated in your bit 1, that is 12. So here he wants the product of HCF and LCM. That is 3780 into 12. That is 45,360. 45,360 is the D answer. That means the bit answer is D. Okay. Now 108 can be expressed as a product of its primes as 108. Now 108, if you see here, it can be expressed as 2 raised to 2 into 3 raised to 3. So 2 raised to 2 and 3 raised to 3, where it is 2 raised to 2 and 3 raised to 3. This is our answer. So that means option D is your answer. Okay. So you see here we just need to understand when to take the LCM and when to take HCM, and it will be fine. So this is for case study. Now let me take one more case study. Okay, before we wind up. So let's take the third case. Case study 3. A mathematics exhibition is being conducted in your school, and one of your friends is making a model of a factory tree. He has some difficulty and asks you for your help. in completing the quiz for the audience. Observe the following factor tree and answer the following. X. When you divide by 5, this number when you divide by 5, you will get 2783. 2783 when you divide by y, you will get 253. 253 when you divide by 11, you will get z. Okay? So this factor tree talks like this is the meaning of this. Okay? Now he is telling you find the value of x. X when you divide, so x divided by 5, your quotient is this. That means x is the dividend, 5 is the divisor, and 2783 is the quotient. So you know that dividend is equal to divisor into quotient. So divisor into quotient, that means 5 into 2783. You multiply this to, you'll get the answer. Okay. So let us see. Let us try to see the calculation of this. See here. What is this? So x is equal to what x value will be 5 divisor into quotient is the dividend. So 5 into 2783 is 13,915. That is your value of x. 13,915 is option B. So B is your answer. That means your x value, let us write it down, 13915. That is 13,915 is your x value. So if you divide this by 5, you will get this as the answer. Okay. Now, next question is find the value of y. You want to find this. So, dividend, as I told you, dividend is equal to divisor into quotient. Dividend is equal to divisor into quotient. So that means dividend divided by quotient will give you divisor. So y will be equal to 2783 divided by 253. Your answer is 11. So that means answer C is your option. That means the value of y is 11. Okay. Now for what is the value of z is asking. Z is here. So z is here. That means 253 when you divide by 11, you'll get an answer which is the value of z. So 253 divided by 11 is 23. That means z value is 23. That is your option B. So B is your, that is 23 is your answer. Okay. Now question number 4. According to fundamental theorem of arithmetic, 13915 is a composite number, prime number, neither prime nor composite, even number. Now if you see here, a prime number, as I said before, in case 1, a number having only two factors. It has got only two factors, then we say it is a prime number. That means which are those two factors? Should be number 1 or the number itself. So number 1 and the number itself. But if you see this, this particular number is ending with 5. If a number ends with 5, it will be divisible by 5. The number ends with 5, it will be divisible by 5. That means in addition to 1, the factors 1 and 13,915, it will have 5 also as its factor. That means it's having more than 2 factors. That means it is a composite number. So because it's ending with 5, it's a divisible by 5. Therefore, it is a composite number. Okay. Now the prime factorization of 13915. Now if you see this tree here, 13,915 is here. So divided by 5, then divided by 11, the quotient again you divided by 11, then you got 20. That means if you want 13,915 can be expressed as 5 into 11 into 11 into 23. Okay, so 5 raised to 1, 11 there are 2, so 11 raised to 2 into 23 will be a prime factorization. So if you see this, 5 raised to 1, 11 raised to 2, and 23 raised to 1. This is your answer. That is, C bit is your answer. So your answer is bit C. Okay. So this way we just take this the questions with case studies we have taken for real number system. So I think you will have a clear idea by now. Therefore, so thank you for watching this. And I want you, if you have understood the thing, please click on the subscribe button and the like button and hit on the bell so that you will get all my updates. And I'll be posting some more uh, case studies concerning with the other chapters in due course. So you please see that you understand the case studies because nowadays it is a practice that application. This is actually an application. So you get an idea of where exactly we are using what we are learning. Mathematics, you say it's an abstract subject and we don't use it. What is the use? Why do you have to learn mathematics? And mathematics is a headache for people. So this tells you that tries to create an interest in you that yes, we need to learn it so that we can know where we are using this. Okay, so that's why please click on the subscribe button and